Hi guys, this is Steve sitting in the race car again. Welcome to episode 2 of the Spridget race engine building series. Today we're going to talk about getting the heads ready to go to the machine shop. So let's go to the workbench and get started. Don't forget to subscribe. Okay, so here we are on the workbench, and I've got one of my complete heads that came off of the cores that I have. This is just a stock head, nothing real special about it. It is a later model head, the 1316 head, a smog head as everybody calls them, because it has the smog inlets here, and somebody had put some plugs in it, so it was obviously came off a car that somebody had removed the smog from, and I don't even know what this is. It's some kind of guarantee stamp that somebody put on there, but that's going to be taken off of. So all that tells me is somebody's messed with this head before. So it's still got the stock spring set in it and stock valves. And then laying next to it is a half a head. I want to talk about that briefly. And then also on the workbench is a headstand that I built. I want to talk about that. And I want to talk about some tools that I have going on here to remove valve guides. Okay. And I want to talk about spring removal tools real quickly here, because I've messed with that over the years and I kind of have a favorite way of doing it. So we're going to cover that. So let's go back to the heads. So the big thing that I look for in a head, besides just, is it in good shape and has it been messed with too much? This one clearly hasn't. It may have been skimmed. I have no idea if there's been material taken off. I have not CC'd these stock heads yet, but that'll come in a bit. We're going to do that in another video. But the main thing I want to talk about is the valve seats. So this one, you can see I pulled one valve out of, and it has no hardened valve seat in. And I just wanted to show you folks that have never really looked at this closely, if you're just starting out, kind of what that looks like. So I've cleaned it up. I used a simple, just a wire brush on the end of my drill, and I pulled a valve out and I cleaned it up so we could look at it really good, so you get a good view of what that looked like. And what one looks like with a valve seat, a hardened seat in it, one of the smog seats, or I'm sorry, unleaded seats in it, it looks like this. Okay, so you can clearly see the difference. Let me kind of point that out to you. There's a hardened ring in there. I can actually feel it with my fingernail there. And you can clearly see a machined ring that's been placed into it. So you can tell the difference between the two when you look at them. Sometimes you got to clean them up to see that, to be sure of know what you have. But I'm pointing this out because when I'm building a race head, one of the things that I want in a new race head is one without the hardened seats in it. Now you can deal with the hardened seat situation if that's all you have, but for my purposes and for what this video is going to show you, we're going to basically build our race heads out of non-hardened seat heads. And the main reason is because it requires a whole lot less work, and I can open these and work these valves, seat areas by myself at home with a Dremel and some other tools to get bigger valves in, which is what our goal is. We're going to put bigger valves in all of these. Okay, so we're going to move on to the tools here real quickly, because I want to, here in just a minute, I'm going to show you how it all works. I'm going to show you how I take the valve springs out, okay, which is not that complicated. Anybody knows how to do that that's ever done this before. But I'm going to show you how I remove the valve guides. There's one that's still got a seal on it. How I remove the valve guides, and I built a process for that. It's just made my life a lot easier just working on heads. So we're going to move these out of the way here for a minute. And the first thing I want to talk about is my stand here. Now, for years, I didn't mess with the stand. I did not have a stand. I'm moving things out of the way here. But this has just absolutely been a lifesaver for me. Started doing more engine work, And boy, I wish I'd have done this the very first time that I worked on a head, because it just saved me so much effort. And so, you know, I just basically got tired of kind of throwing these guys around on the workbench and struggling with tools. So I decided to get me a little work platform, and I would highly recommend it. It's simply some scrap square tubing I had around the shop, and all I did was put some 3/8 bolts in it, and then I put them in the appropriate place and tacked them in. So I'm going to show you how the head fits on there nicely. I've got a little piece of foam up here just to kind of give it a nice softer work surface, and I'm going to show you how that works real quickly here. Okay, so now I've got the head up on the little work platform I have, and you'll see the bolts stick out through the stud holes, and that's the big thing. And it also just gives me a platform to work from, and it allows me to take this guy right here, okay, and basically pick him up and throw him in the trash can. Okay, and I'm advising you that that thing is the hardest thing to use on these little heads, and I struggled with it for years, and I just got tired of it. And that's one of the big reasons I built the platform, because I went to one of these stud valve spring removers, and that just made my life so much easier, because now what I can do is just screw this on here, and of course you can use this while it's on the car, but now I can work these guys with these springs so much easier. I'm kind of holding the camera here, so give me a second here to kind of get the tool on here so that it works properly. So there we go. It's doing it one-handed. And so you see now it's so easy to just work the springs. Okay, but now you got to hold the valve in place. And so all I did was I simply cut myself something. It could be a stick, it could be anything. I had some PVC laying around, so I cut myself a piece of PVC the right length so it would sit here, and then I could put the handle on the valve spring compressor and get it lined up just a little bit better here. I could do this a lot faster, and I'm going to show you that here in a second. And then I could, you know, compress the valve, no problem. There it is, locked down. And then just remove the little keepers. There we go, there's one, and here's two. I usually use a magnet to do this, so I'm gonna leave that in because I'm doing this one-handed. But that's how simple it is, and I can simply just go from valve to valve to valve to valve and just drop these things out so easily, so much easier than that old, the other way of doing it. And plus, this gives me a tool I can use while the head's still on the car if I ever choose to do that, which I've never really had a need to do that. But this is I just can't more highly recommend building yourself something like this if you're going to do this, because it's not just about building the engine. Where this is going to come in really handy is when you're running a race car, you're going to want to refresh the head multiple times throughout the life of that engine before you even pull the engine out. And so I tend to take my heads off, you know, at least once a year, once a season, or maybe twice a season, and just check the valves, clean the head up really good, maybe relap or redress the valve seats so that I don't have any leakage, keep my performance up really good, check everything. And by having this stand, because I can pull my head off and just work off this platform and inspect everything really good, it really has made my life better when I'm working on heads. So there you go, make yourself a stand. That's what I did. Okay, so reposition the camera there so you can see everything a little bit better. And now I'm just going to go about removing all the valve springs. I went and got my little trusty magnet to help me get the little keepers out. And we're just going to go at it. Okay, so removing the valve springs took all of maybe 3 minutes, maybe 4 minutes. That's it. Pretty easy. So I'm just gonna take a screwdriver and pry off these valve seals. Let me go get a screwdriver real quick. Okay, so yeah, they're pretty crunchy. So there we are. We're just gonna pop them off. And now I'm gonna take, now I'm gonna take my magnet and pull these spring perches off of there. This has a little perch for the inner spring for the set that was on there. I could see that. And then there's also should be a on each one of these, or some of them anyway, there should be some kind of shim. So there's a shim there. I'm gonna wipe it off here so we can read it. There. This is a spring shim, and it says, let me wipe it off one more time. It says that's a 106 or something like that. I thought it 0.06, so this is a 60 thousandths thickness. So don't throw these away. Don't throw these away. You might need them, but I'm gonna throw away all these perches and the springs because we're not gonna use them. Okay, so now we got all that off of there. I'm gonna flip the head over. Okay, now with the head flipped over, we can just sort of sit here. I just want to take a look at it all. You know, it's pretty doggone dirty. A lot of carbon and gunk build up on it. So my next step is to put it in some mineral spirits and take a wire brush to it and just get it good and clean. The other step, the thing that I'm going to do is I'm going to remove these little plugs that somebody's put in there. I don't like this kind of plug. I prefer a little Allen screw. We call them a grub screw, I guess. But a little screw that'll sit flush. So we're just gonna take those off. And we're also gonna work to get this guy out of here, this bypass tube out of there. Now that could be problematic, and I'm gonna try my best to get that out of there. I may end up leaving that for the machine shop to kind of drill that out, but I'm gonna probably get it out of there. So and then we'll take all the studs off that are left on here, and then we'll come back and I'm gonna show you how to take out the valve guides and how I do that. So be back momentarily. Now we've got the head all cleaned, and all I did was put it in some mineral spirits and take a brush to it, and then I washed it off with some soap and water. And then I just to keep oil on it, I put some WD-40 on it, just to kind of keep it oiled down so it doesn't flash rust anywhere. Anyway, so now what I want to do is talk about getting these valve guides out, and you can have the machine shop take these out. That's fine and dandy. You know, personally, I like doing everything myself, and so I use an air hammer to knock these out. And basically, here's my little air hammer. And then I made myself a little tool. This is not a real fancy tool. It's just a piece of bar stock. I mean, if you have the ability to turn something on a lathe, this is real easy to do. And I made it so that you could basically put it on top of the guide and then just air hammer it out. Now, this other sleeve here, this other portion here, this is just the guide part right here, just to kind of keep it more or less centered. And this is the hammer part. And I made it pretty long here because I'm gonna show you when we go to put new valve guides back in down the road, how I use that space to space things out. But for now, we're just gonna put it on there and beat them out. So we'll go get that done.
Okay, so all the guides are out, and these are also going to go in the trash can. So now we have a clean head, and yes, okay, we could have had the machine shop do a lot of that work. You could have had them press these out, or you could have pressed them out. You don't have to use an air hammer. You don't have to build a little widget like that. You can make all kinds of things. In fact, just getting them out of here, you could just use something and a hammer and driven them out if you want to do something that simple. Main thing is just try not to hurt the bores that the guides were in. And then we've sort of cleaned up everything. I haven't run a tap and everything, but now this head is ready to go to the machine shop. So what are we going to do? So that's the big question now. What are we going to do? We've got to put a list together. Now that we have the block ready, and now that we have the heads basically ready for the machine shop, things are kind of cleaned up, we need to make a list. We need to make a formal list to give our specific instructions to the machine shop. And the reason we wanted to do that with both the head and the block at the same time is get the heads crack checked, okay? Because we're about to spend a whole bunch of time on the heads. And I don't want to do a lot of put a lot of time into the heads until we know there's no cracks or anything else. So we're going to get them cleaned really good, get them crack checked, do a few basic things to them so that we can just really inspect them well. And then while we have the heads back and doing our work on the heads, machine shop's going to be doing other things on the blocks. We're going to be line boring. We're going to be boring the cylinder bores out. We'll do we'll do the crack checks. We'll do all of that stuff. But there's quite a bit of work to do on the blocks. So I'm going to make a list. And that's really the last part of this video, is to show you my list.
Okay, so this is my machine shop to-do list, and it may seem silly to go over a to-do list in a video, but there's a lot of information here, and I think it's worth doing. If you don't want to watch, that's fine, but it kind of gives you my thought process about how this build is going to go together. So there's 15 items. I'm going to give them just 3 BMC A-series blocks and heads. And the first thing we're going to do is remove the oil galley and freeze plugs and the old cam bearings. I did not pull the cam bearings out. We're going to remove the water crossover. It's not really a plug. It's the little crossover outlets on underneath the water necks. There was a couple of them in these heads that these 3 heads that basically I was starting to mess up pretty badly by taking them out. They're frozen in place, and I decided to not pull them out myself, so I was just going to let the machine shop do that. They have better tools and facilities for that. It'll make a quick and easy job for them, so I'll pay them to do that. I'm going to have them clean the blocks and the heads. They've got a ultrasonic cleaner at my machine shop and a hot bath, and they'll get them really clean. And then I'm going to have them inspect them. They'll do a visual inspection, and then based on what they find, we may check for cracks. There's a variety of ways to do that, but that'll be a conversation we'll have. That's why I say, hey man, if you see any problems, call me. If you see anything big, I'll bring a replacement. So this is the time right here to go, before any machining work is done, to go, hey, am I starting with good stuff, or do I need to find something different? It's time to stop right there by number 4. Okay, after that, then we can do the machine work. So I'm going to lightly skim the heads, and that would be the deck and the exhaust gas, where the exhaust gasket sits, because I want them to skim that too. We may come back and take more off later, but I just kind of want them skimmed so I can begin to start the process. Now, then the next thing I'm going to have them do on the heads is I want them to drill those 2 extra holes I talked about, and I'm going to provide them another head that's got holes already in it, so that they're in the places that have been done before. But any good machine shop can figure that out about where those heads go, and there's other stuff online. So you just want to communicate as best you can where those extra bolt holes go, and they'll work through that.
And then when the heads are done, I want them to call me because I want to get the heads back first. And that'll happen pretty quickly with my machine shop. I don't want them holding everything because I've got a lot of work to do on the heads. It's going to take me a long time, quite a bit of effort to port and polish and get the valves cut in and get the heads just exactly the way I want them. And while they're working on the blocks, I can be working on the heads. So I don't want to wait to get the heads back. So after that, we can move on to the block. I want them to drill and tap the other head bolts in the block. I want 2 of the blocks bored to 20 over and 1 of them to 40 over. Okay, and I'm providing them a set of pistons for each of that, so they can check the spec on those to make sure we get all of that boring done properly, so we have good piston clearance. And then the big operation is going to be this line boring operation where they're going to fit a new crank into each block, and this is a tedious and big setup job for them. So this is what will take some time to put that job in line at the machine shop to get it done. So it'll probably hold up getting the blocks back a lot longer than it will take to do the head work. So we're going to bore and line home the blocks for the new crankshaft caps, and that includes drilling for the 4-bolt main, which we talked about in video episode 1. And then we need to, when you put new center mains on, you got to think about the center main cap thrust bearing, because the billet main caps won't have the thrust bearing seating surface machined to the proper depth. So you're going to have to fit that, and so they will have to cut that in to meet the spec. And this is just standard stock spec, 6 thousandths to 10 thousandths infloat. So they'll fit that up, and they'll check the infloat with a set of bearings, with a set of thrust bearings, and they'll check all that. And then while they have it set up on the line boring, they'll put a different cutter in, and they'll cut that extra seating surface just a little bit if they need to. So then they're going to I want them to dry build the whole short block, because I need for them to measure where is the piston top in relation to the deck of the block. And when they figure that out, I want them to deck the block to where I have a 5 thousandths piston to deck clearance. Now that number came from in episode 1. I was talking about how to use my spreadsheet to determine kind of my beginning design, and this is where I landed. I landed that I want 5 thousandths piston to deck clearance. Okay, and then by then most of the bulk of the work is done. The rest of these items are simple items. We're going to thread the oil galley plugs for grub screws. So I'm not going to use the brass plugs because I want to be able to take the grub screws in and out anytime I want to clean the oil galleys without having to go back to the machine shop or drill out the brass plugs. So we're going to put grub screws in, and then we're going to install freeze plugs and install the cam bearings. And the last little bit there is you need to take a cam. Anytime you put cam bearings in, the machine shop needs to have the cam so that they can test fit the daggum thing, because I can assure you they won't always get the cam bearings in there aligned perfectly, and you might have it dragging one of the bearings a little bit because the cam bearings are pretty narrow, and they might get them tilted just ever so slightly. So you want them to test fit that to make sure they don't have to rearrange one of the cam bearings to make it, as it should be. So anyway, that's the machine shop to-do list. So I managed to make it over to the machine shop, and you can see my stack of stuff at the loading area of the machine shop. And that's the end of this episode 2, and we got a lot more to do, a lot more to talk about. I'm going to get the heads back pretty quickly here, just kind of roughed out and checked for everything, and then we'll start the porting process. And so watch for episode 3 coming soon, and don't forget to subscribe. Thanks.